Well, good evening and welcome to episode 90. Can't believe it's 90 of Codebase Alpha. And this evening we're going to carry on with the tutorial we're working through to build a platformer game using the Haxe Programming Language and the Haxe framework or library. So let's pop back into the code straight away. But hopefully this week there won't be any interruptions. Last week we had an outage on my ISP, and I think that coincided also with some problems at Twitch. But I was taken out for about 10 minutes. So hopefully, fingers crossed, that's not going to happen this evening, and we'll be able to kind of carry on all the way through. Now, last time we did kind of end on a sour note. So I hate ending streams when I haven't solved a problem. And last time we had the issue where on our platformer, the player would fall through the floor, even though before we started working with the tiled level editor, we'd kind of handcrafted a little level, and the collision detection was working fine. The player would run along the surface absolutely fine. When we moved to tiled, it appeared as if that didn't work anymore. And I spent quite a long time, I think, just trying different things and just trying to figure out what was going on. And as is kind of traditional on Codebase Alpha streams, after I'd given up and stopped the stream, about 2 minutes later, I fixed it. So let's go over into the code and have a look at what that was all about. So here we are. We're here at the play state module of the Haxe code. I'm going to sneeze. Excuse me. And this is where we actually load the level, and we were concentrating very much on the code within the level loader part of the code. So we're over here, and we're looking at this, and we're looking at the solid flag, which defaults to true. So we loaded our main kind of part of the layer, the main layer, which was the platforms. And when we loaded the background, we set the background to be not to be solid. And yet still, the player would fall through the platforms. And what the actual problem was, and this was by no means intuitive, and I actually still don't quite understand why this is the fix. It's actually to do with the cameras. So we set up a camera here. We set our camera to. There's a camera that's kind of default camera that is a part of the Haxe scene, and we set it up to follow the player. And this line here says we're going to have a camera which follows the player, and it's going to follow style is going to be as per a platform. So basically, it's going to kind of have the player near the center of focus, and as the player jumps up and down on the platforms, excuse me, the camera will follow him in that manner, in a manner of a platform game. This next line is the problematic line. This is what's setting the camera bounds, and it's setting the scroll bounds to be a rectangle starting at 0, 0, which is the top left-hand corner, and extended the width of the map and the height of the map. The height of the map is going down, so it extends to the bottom right-hand corner. So that was what we had before. So if let's restore what the code was before. So this is what it looked like when we finished the stream last week. And if I run this now, if I do Control Shift B to run our build task, we're going to execute. We're going to build and then execute. We'll create our platformer, and you can see our player just fell straight through the floor. And it was a bit of a mystery, to be honest, why that was happening. So let's just go back and actually change this variable at the end here. So this variable on the set scroll bounds rectangle is this one up here. So we get this nice IntelliSense, and it says it's an optional parameter called update world. It's a boolean and it defaults to false. So currently update world is false. An update world has a rather strange definition, and I've not been able to get to the bottom of what this actually means, but it says whenever the global quad tree's dimensions should be updated to match default false. Well, it's strange if I set that to true. So we're going to update the quad tree, and a quad tree. You understand maybe what a binary tree is. A binary tree is each node has 2 leaf nodes. A quad tree, each node has 4 leaf nodes. It's going to update that the world to match the camera's scroll bounds. Now, as to why this makes all the difference, I don't really know. I just don't understand. However, it does make all the difference. So let's save that. Okay, and so I'm just trying to figure out because we've compiled. I was wondering why we had the 3 changes there. If I run this now, so Control Shift and B, we need to restart that task. We'll start our level again, and you'll see our player helpfully stops at the right place. So we should now be able to move backwards and forwards. We should be able to jump up onto the platforms. Oops. Need to upgrade it. You can see this is the kind of the platformer follow, the way the camera kind of follows us up in the air as well. Okay, so we've got a kind of game which actually will run now. Now, one of the issues that you can see when we start this game, if we just start this game again, so Control Shift B, restart that build task. I just guessed where the player should start, and the player kind of just drops in from the sky and lands here. We really want the player to be to actually start in this position here. But rather than trying to work out how to position the player, we really could do with a way of setting that dynamically per level, so per the map. So we're going to look at that. I think just before we do look at that, let's have some music. So let me know if that music's at the right volume. Okay. So what we're going to do is use our map editor to actually define where our player is going to start. So if we look at the code, we want to go to the where the player gets created. We're creating the player at 6416, which is in midair, and they drop down onto the platform, and away we go. We want to change this, so when we load the level, the player is created at a position that the level is defining. So we can, in each different level that we design, we can simply put a marker in the map to say where the player is going to start. So let's look at that. And we're going to use our map editor, which is tiled. Now, tiled is a very commonly used map editor. It creates these TMX files, and the TMX files are also supported by a wide variety of game development frameworks and systems. And you can see, actually, if we go back to our code, we have in our level loader, we're referencing these tiled layers and tiled maps and tiled objects and tiled tile layers. Here, the editor tiled. This is a whole kind of library, add-on library, which is actually devoted to supporting the tiled editor. So it's really nice. We got really good integration between our tools. One of the things that kind of characterises the way we're developing this is that we're using kind of best of breed tools. So we've got a nice level editor, but it's not integrated into our main development environment. We've got Visual Studio Code for our lightweight code editor stroke IDE. We've got the Haxe language, and we've got the Haxe framework or library to work with. And that's a kind of there are tools you can get, especially 3D tools like Armory 3D, where it's all integrated into one UI. In fact, it's integrated into Blender. But here we're working with kind of best of breed tools, and so that's quite a nice way of working. Especially with 2D, it's not perhaps with 3D games. You might want to work in a slightly different way, but for 2D this is quite good. Okay, so we're going to create a new layer. These are our layers here, and we've got objects as well here. So we're going to create an object layer, and we're going to call this object layer player. Okay, and you can see it's got a different kind of symbol. This is a tile layer, main and background, and then we've got this object layer, and we called it player. Okay, and we're going to place on this layer. We're going to place a marker which is going to indicate where our player is going to go. And we might also use the actual player icon or tile here. And we're going to say our player is going to start there. We'll say so. That's how do we drop the player in? We need the stamp tool, don't we? Okay, fair enough. What's this then? So that's an object. So how do we place the object? Oh, we want to insert a tile. Okay. Layer. Let's have a look what we've got here. Edit polygon, select objects, insert rectangle, insert tile. So that's it. We're going to insert that tile, and we want to insert that our player to start in that position. Okay. Then we get kind of an object property sheet over here. I know it's very small on the stream. You may not be able to see it. I don't think I can make it any bigger, unfortunately. We're going to give it a name. We're going to call it player. We can also give it a type. We're not going to give the player object a type. We're going to use this type a bit later on to define different kinds of enemy that we're going to be populating our platform or world with. And you can see that it's a 16 by 16 tile, and this is the X and Y coordinates going to start at. So 47.63 and 206.89. However, you can see our object here has got the label player, which is the name we've given it, and that's where we want our player to start. Okay. So what can we do with that? Let's save that. Okay, so that then should transfer that TMX file over to our data layer, our data directory. So we should see that over here we have level1.tmx has changed. Okay. So let's go back to our play state. So we've got our player here. This is a public property called player, and it's what this syntax means here. We've got this kind of brackets default and null. This means that it can be the pudding. Welcome to the stream. Good to see you. Have some electric elf hype to see. Welcome in, and be careful of that of that pudding. Oh, there was a follow as well. Thank you for Alex. Alex, thank you for the follow. Didn't see the alert for that, so thank you so much. We're really getting close now to our 400 target, so thank you. Yeah, so this is the equivalent of in C# you might see it be a property with a get set. This means we've got a getter, so anything outside of our class can get the player, but null means it's basically it can't be written to. So we can only basically set up the player within our within our class, basically. Okay, so we've got that. Right. So the next thing we need to do is go into our level loader. In our level loader, we're going to get that that player layer in. Okay. So it's very similar to how we pull in these various layers here. This is going to be an object layer though. We've already got the imports for tiled object layers brought in. So we're now going to go and grab that. So it's very similar to this kind of idea. So we're going to say basically obviously it's not a given that there's going to be. This is Haxe 4, by the way. The pudding. Yes, it's Haxe 4. So yeah, it's we've got quite a lot of new functionality in the new version of Haxe. Right, so we've got our map here. We pulled our map in. It's in tiled map. It's not a given that there's going to be a player layer present in every level. So let's make sure there is one. So we'll do a get layer on that. Okay, and we're going to get the player level. When we called it player, and if that's not null, then we can actually go and do something. We can actually manipulate. We can pull out that player position. So we're going to say var player layer, and that's going to be a tiled object layer. So this is the slight syntax difference and catches me out currently. Is that we define the type of the variable after the colon. So it's a bit similar to F#, I guess, in that respect. And this is going to be a tiled object layer. This one here. Okay, and we're gonna cast basically the tiled map get layer. So we want this code here. We're gonna cast that as a tiled object layer. Okay, so because this is actually getting a tiled layer. You can see it's getting a less strongly typed version. So we're going to cast it from a tiled layer to a tiled object layer, just as we did up here, where we cast the tiled layers here to the tiled layers. Tiled tile layers. A bit kind of a tongue twister. Okay, then we're going to have another variable, which is going to be player position, player pos, and this is going to be a tiled object. Okay, and we're going to go and grab the player layer objects. Now, there's only one object we've created. Surly Dev, welcome. I'm quiet, am I? Am I really quiet? Is it just because I'm not close enough to the... Is that better, Surly? Let me know, because I don't want to have audio issues. I had a couple of them in the past, and they're a bit kind of tricky to deal with. I'm very well. Is it a little bit better? Let's see if we can just try and boost that audio a little bit. How's about that? Is that any better? Jetson, welcome to the stream. Good to see you. You guys have some hyperspatial hype. There you go. Have some ALF. You're on a laptop with no external speakers, so hopefully, I don't know if the pudding and Jetsam, if you could let me know if my voice audio is okay. Surly was finding it a bit quiet, but you got 100% up full. No, I find that with it sounds good to you, Jetsam. Thank you very much. I find that with Code Rushed, I have to have him turn right up, and if Rory's on, then I can hardly hear Rory a lot of the time. And then other times it's very, very loud, and there's no kind of happy medium sometimes with some streams. But so hopefully that's better for everyone. Okay, so we're going to get we're going to pull the player position, and it's going to be position of the one object that we've got in there, which was that player. If you remember, we dropped the player icon here. This is the player object here. We can actually lock that layer now. That's the player. So we're going to get the position of the icon there. Now, interestingly enough, in tiled, the 0, 0, the origin is actually going to be the bottom left-hand corner, whereas in Haxe Flixel, it's the top left-hand corner. So we're going to have to adjust for the height of our tile. So let's get the position of let's get the player first. So this is player layer. We're going to get an object. So there should be an objects array, and we're going to get the first element on there. And we could try getting it by name actually. I wonder if we can do that. So objects dot we want like a lambda. Let's just stick to the simplest case because we know it's the only object on that layer. So we'll grab the first object from the array, and then we'll say state dot player dot set position. Okay, and that's going to be player pos dot x comma player pos dot y, and I'll show the fact that the offset is not quite correct because of the difference where the origin is in tiled and in Haxe Flixel. So let's leave it like that. We'll just finish this off with an else, and oops. And we'll just trace here. We'll just send out player layer was not found. This for level. Okay. Right. So let's see the effect of not offsetting our player Y position because of the difference. Save, and we'll run the build task. Mark tinkers with his settings a lot. Yes, he's also got so here, this is interesting. So you can see our player is actually sunk into the ground. The player's there. I don't know if you can see it on stream. It's actually sunk into the ground. That's because we've got to account for the fact of the different origin. So as I say, in this game we've got the origin of the tile is top left, whereas for tiled editor it is bottom left. So let's sort that out. So we're just going to subtract 16 from that Y coordinate. So just take minus 16 off that, and we'll put a note to ourselves. Adjust for tiled origin. We save now, and we run. What we can actually do as well, we can go back to our play state and we can remove that code, I believe. I think we have. Do we have to mark it with question marks? I'm not quite sure. Let's see if that will actually build. Yeah, so now we sit in the right place in our game, and we can jump up and down, and we can run, and we can skid. Okay, so that's pretty good. Now, one of the things that is a kind of a bit of a problem here is if we kept moving this way, we drop off the edge of the level, and actually we want to be going to the right. We need to put a signpost in there. We'll do that. So we want to stop ourselves actually being able to leave the level by the left-hand edge. Let's go and sort that out. So we need to go now to we're in our player, in move. In move here, basically what we want to say is what is the best place to put it? We can put it down here. We can say if x is less than 0, and then x equals 0. Let's run that. Pure Stable, welcome. Yeah, we've got our little platform character actually sitting in the right position on the platforms now, and that's actually the position we started at is being set dynamically via our level editor. So not only are we learning about Haxe, and we can't run off the edge now, which is good. Not only are we learning about Haxe, we've also got some kind of some good use of the tiled editor as well with our tiled object layer. So here we got a drop off. If we fall off there, we're going to die. So that's the end of the game there. So we're going to need to have some kind of end of game things going on there, respawn or whatever. Okay. Early devs here, yes. New question: is it poor practice to use? No, I don't. I think that's fine. I think that's fine. That's like a tertiary kind of statement. They're putting that on. I'm quite happy with that. Yeah, no problem at all. Okay. So I think that's everything we needed to do in our player. Okay, that's good. Okay, so I guess we need to kind of start to think about what's the kind of things that we normally come across in a platform game, and the first thing is going to be things that we want to collect, like coins or something like that. Pure Snowball, you're okay with tertiary expressions personally, but it's a divisive topic. It is. Yeah, I mean, I'm absolutely, I would use it, no doubt about it. So in this case, as you say, in Haxe, it is an expression, not a statement. Yeah, it's not a tertiary statement; it's a tertiary expression. So we are basically setting the value of x in an expression, which is a conditional expression. I guess we might call it rather than a tertiary. So you normally only use it if it's brackets and both sides have variables, because it helps with debugging. It's just a concise way of saying exactly why I said, isn't it? It's exactly that in a concise fashion. But we're gonna kind of leave it in that form basically. So right, so let's have a look. I think what we ought to do before we go much further is start organising our source files. In the source directory, we got our source files here, and we could end up with quite a lot of source files. So let's start to create some directories to put our source files in. So we're going to create a new folder here. I'm going to call this utils. We're going to create a directory here called objects. We're going to create a directory called states. Okay, so let's start moving some things around. So this level loader here, that's a utility. So let's move that into our utils area. Player is of course an object. Let's move that into our objects, and of course our play state is a state. And here by state we're really thinking of in very broad terms as being like a level. we're going to have menus as well to start off with. When we first kind of create our game, we're going to have some menus like to start playing or to quit or whatever. That'll be a state as well. The fuel stable says maybe I would use a built-in function max and min. Yes, you could do that. If we talk shaders, all conditionals are bad practice. You know, of course, with a shader, it's because you can't guarantee it's going to evaluate correctly, because it can evaluate to both the if and the else statement, can't it, in the shader? And I'm kind of hoping to get onto shaders with Haxe at some point in the future, because there is a complete when we go to the heaps library, there is a shader language built in with that, and it's so that's all kind of GPU optimized, and everything happens on the GPU with the heaps library. Here it's very much like it's very much in the vein of Flash games and Swift files and things like that. But they were actually building HTML5. We're building JavaScript here, but I do want to try and get into maybe not 3D on the GPU, but at least 2D, and maybe we can play with some shaders on that. That should be quite interesting. Okay, so we've moved our objects around. The problem with this now is that we need to actually define what package these are in. They were all in the default package before. This is the level loader, and this has got to be in the utils package. Okay, so we'll save that. Our play state has got to be in the states package. And our level loader and our player is going to be in the objects package. Right. Let's build and see what happens when we build. Okay, so we get some unknown identifiers. Okay. So in main we get unknown identifier play state. Okay, so why would that be? Let's go look at our main. We're going to need to import our play state. It's not there, so if we hover over it and we type control dot, it says import states.playstate, so we do that, so we bring that in. Okay. And let's try building that again and see what happens. So level loader didn't find this time, so we got a level loader, so that's in play state. Here's level loader. This is going to be utils.level loader. Try building again. Now it's saying play state not found. So this is in our level loader. So we'll have to import states.playstate. Oops, that's the wrong place. That's going to be in level loader. Okay. So now it's saying that player's not found. So player's an object, isn't it? So where is player? We're saying this is in play state. It didn't find object. So over here, so it's player. Once again, control dot. Import objects player. And hopefully that should be enough. It is. So there we now we are. We're back into a working game. So we've kind of reorganized our source files in a slightly more logical way, and also we've created some Haxe packages. Okay, what else have we got here? So 8 level loader main. Okay, that's good. Okay. Right, so let's have another object. Let's have a coin object. Right, so okay, so what we're going to do first, before we create any, our coins, we're going to have some we're going to create like a register class, which is going to hold things like our score, how many lives we've used up, and how many coins we've collected. There's some basic state information for the game, which we're going to use eventually to display on like a heads-up display, so we can kind of see how far we're getting. Cody Beard, welcome to the stream. Have some electric Alf hype. Good to see you. Okay, so we're going to create this, I think, in the root of our source file. So let's create a new file. We're going to call it reg.hx. Okay, so this is going to be a class. Reg. Let's have some static variables. So public static var score. This is int, and it's going to start off at 0. We have a public static var int. So not int. Oops. This is going to be the number of coins we've collected. I think we'll have something along the lines of if you get a certain number of coins, you get an extra life, something like that. And then public static var lives int, and we'll have 3 lives. Cody Beard, did I get my AD woes sorted? Well, that was an interesting weekend I had. Luckily, we had plenty of support. But so what happened is the domain controllers got trashed on the move, and we had to kind of build new domain controllers. Upshot of that is we got Windows Server 2019 domain controllers out of it, but it was actually, luckily, the old domain controllers still existed in our previous cloud hosting service, so we were able to kind of do the sync and recreate the primary controller, and I think the secondary controller is probably still even now replicating. So as soon as we did that, we had a working domain again, so we could actually do stuff. And then it was a matter of tracking down why individual pieces of software wouldn't work properly. And the main issue we had that went into Saturday was our service layer couldn't connect into CRM, and it was a load balancer issue. The load balancer didn't get transferred from the previous host into Azure, so we had to create a new one. And once that happened, and we got all the IP addresses and DNS names had synced up, and everything worked fine. So yeah, we got it, but we're now only 50% of the way through. So we've got another 150 servers that got to move, and it's the way it's gone so far. It's all going to be seat of the pants kind of stuff, I think. So it's going to be interesting life. Okay. So we want to play with coins now, don't we? So we've got a coins counter, so we can count up how many coins we've got. Let's go and find a graphic for our coins. So over in my D drive, I've got some assets, and images. What items or items here? So we got a whole bunch of kind of things here. We've got, let's make this bigger. Okay, we've got an animated coin which is spinning, and then we've got some nice power-ups here, apples, little stars. Looks like bars of chocolate. I'm not quite sure what those are supposed to be, but we've got a spinning coin here. So these 1, 2, 3, 4, 5. These 5 sprites here on this sprite sheet can make up our coin. So let's go and grab that. We'll copy that, and we'll go over to our application, our little game, and that's in the dev directory, platformer, and we're going to drop that into assets, images. Okay, drop that into there. Now, one of the nice cool things about Haxe is what they call macros, and macros are not like C++ macros or C macros. They're quite a bit more sophisticated than that. They're actually ways of injecting segments of program into your application. And we've got this thing called asset paths here, and this has got a build macro defined. This build macro is actually one that comes with Haxe Flixel, and what it's going to do basically, it's going to look at the assets directory, and it's going to build us some strongly typed connections basically to our data, our images, our music, and our sound files. We'll see that working. So we've just dropped the items.png into that images directory. If I build now, then we should that build task will run. So that's a task that macro runs at compile time, and it should now enable us to reference our coins. Okay, so our coins are going to live in the object folder, and we're going to call it coin. Checks. Okay, so we can probably close the reg. Cody Beard, he says, I say don't bother trying to migrate the DCs. When we did it, you just built new replacement ones. Well, I think we're going to have a kind of a drains up tomorrow, and I'm pretty sure that things like building the domain controllers and transferring the roles and building all of the load balancers ahead of time is going to be what is kind of on the cards, really. You can see here we've got our because we've dropped our file, we created our file in the objects folder. It's automatically picked up that we're part of the objects package here. Okay, so we want to class coin. That's going to extend. That's going to start for the Flixel sprite class. Virtually everything in terms of game objects start off extending that class. Okay, I'll just save that. Right. Getting a bit dry today. Okay. So we want to define really how much a coin is worth. How many points is it worth? Oh, I don't like that. I like to see my brackets looking like that. I don't like the Java style of brackets. Okay, so let's define a private variable, private static variable, which is a var, and we're going to say it's the score amount, and that's an int, and that's going to be 20 points per coin. Okay, now we want a constructor for our coin class. This is a public function, and it's going to be called new. Our constructor's called new. Okay, and we're going to pass in the position where it's going to be created. So on X, oops, which is a float, and Y, which is a float. Okay. Right. So what should our constructor do? Well, we want to load it. We want to first we should call the superclass constructor. Oops, come on. And then we want to load a graphic to represent our coin, little spinny coin that's going to be there. So we're going to use the load graphic function. Load graphic is a member method of the Flix sprite class, so we've extended that, so we inherit quite a bunch of functionality from there. And this is where our asset paths come in. So if we said asset paths, okay, okay, why isn't it picking it up? We'll just try starting the type. Interesting, it's not picked up. Not picked it up. Let's see what happens if we carry on. So animated, it's going to be an animated true, and it's going to be a 16 by 16 sprite. Let's just save that. Asset paths. Oh, I spelt it wrong, that's why. So let's just get rid of this. There we go. And you can see we've got items.png. So it's not. It's the asset paths class has basically picked up all of the files which we've got in our assets directory structure. So we want items.png. Okay, so there's our graphic, and now we want to define the animations. And Copper Beardy, welcome to the stream. Good to see you. Have some Electric Alf. Electric Alf a lot. Actually, I have a salute as well. I haven't used Alf's salutes for a while. Welcome to the stream. Good to see you. Enjoyed I've been lurking on your marble streams. I haven't said an awful lot, but I quite enjoy your marble streams, Copper Beardy. It's very relaxing. Okay, so we need to set up the animations. What we want this coin to spin. Okay, and it's going to be. We need to give our the animation a name. So animation. We're going to add an animation, and we'll call it spin. And then we need to define an array of the frames which make up the animation. And if we go back to look at what the animation was, where's the best place to look at it? It's here in images, items, and you can see it's these 0, 1, 2, 3, 4. So it's just the 5 frames of animation for a spinning coin. So we're going to have 0, 1, 2, 3, 4. So those are the animation frames we're going to use, and we're going to say that there's going to be 16 frames of animation in total. And then we say animation, and then we're going to say play. We're going to play that animation. When we create a coin, we're just going to position it, and it's just going to sit there spinning. Okay. Right, so what's the other thing we need to do? We need to be able to collect coins, don't we? There's a kind of, the basic thing is when we jump up, what's it complaining about there? Let's just save that a second. Let's do a build to see if that's a problem. No, it's not a problem. Very strange. Oh, because we haven't got a comma. There we go. I should be happier now. There we are. Okay, so we want to be able to collect our coins. So we need a collect function. So public function collect. And we're going to call the collect function whenever the player kind of jumps up, lands, or the body of the player sprite passes through one of the coins. So when we collect a coin, there's several things going to happen. The first thing is we're going to increase our score by the score amount, which is here 20. We're going to increase the number of coins we've got, and if we've got 100 coins or more, then we're going to reset the coins to 0 and gain an extra life. So we can simply code that. So we've got our reg class, so reg.coins, we've got score plus equals score amount, reg coins, and we're going to increment. Then we're going to say, well, if reg.coins is greater than or equal to 100, then what we're going to do, we're going to say reg.coins is equal to 0 and reg.lives is going to increment. Okay. And the final thing we want to do is we want the coin to disappear. So we've collected the coin, it's got to disappear. Now that all our sprites have a whole bunch of functions built into them, and the one to kind of destroy the sprite is the kill function. So we're going to kill our coin. That means our coin will disappear from the game. So let's save that. Do a quick build to make sure we've got no build issues. Okay, so we're okay. So what's next? Right. So we need to add these to our play state. So we need to add the coins to our play state, which represents our level, doesn't it? This is level 1, as you can see here. Okay. One thing we can do, rather than create them individually, we can actually create a group of sprites. This is a Flix group. So let's set up a Flix group to be the to contain all the items we're going to create. So this is going to be a public variable items, and it's going to be very similar to, it's going to be a property basically. So this is going to have the same kind of syntax as player, and this is a Flix group. Okay, so we should be able to bring that in. Save. It doesn't know what it is, so we bring the import in. Flixel.group.flixgroup. Okay. Right. So when we create our level, we want to populate it now with the items group. Okay. So let's do that. Let's say items is going to be a new. I'll just move slightly closer to the mic. So that's going to be a new Flix type group. So we can choose a typed group because we're going to give it a type of sprite. So let's see if we can find a typed group. Here's a typed group, and this will have a very similar kind of syntax to your C and C#. So it's got the angle brackets here to give the type. So that's going to be a Flix sprite. Okay, that's going to be a group of sprites. strongly typed. I'm going to add the items to our scene, to our level. Okay. What's it saying here? Should be interesting. The main game object class, a sprite, is a Flix object with a bunch of graphic options. Flix sprite should be Flix basic. So we try Flix basic then. Why can't we type it as a Flix sprite? Should be flixel.flixbasic. We have flixel group type flixel.flixsprite. We want a flixel group. Okay, let's try that. So type T. Interesting. So the game runs. Okay, we'll live with that for a second and just see what happens in a bit. Okay. Let's think. I think the problem is I've set this up wrong. This should be a typed group. Yeah. And I think this should be a sprite. Yeah, I think that's happier now. So what's this say? Flix typed group. Remove that. And we'll just control dot into there. There we go, that's better. Okay, I think that's correct now. So if we just do a run to see what happens. Value number of parameters, so that needs to be like sprite as well. Yeah, of course it does. Well, I think that's correct. So we'll just live with that that red underline and see what happens in a bit. Okay, so the next thing we want to do is make sure that when we collide with these coins, that they get collected. Okay, so that's going to be in our update. Remember, our update function here for our play state for our level is going to get called every frame, so 60 times a second in the kind of setup we've got where we're doing 60 frames a second. So this is going to be called 60 times a second. So this is where we set up the collision between our player and our map. Okay, so we now need to set up some code around collisions with our items. This is why we've created a Flix group. So rather than having to set each individual coin to say, oh, we can collide with coin A, coin B, coin C, coin D, etc., we can say anything that's contained within our group, our typed group, our Flix typed group, we're going to have the same collision properties. So here we can basically say that we're going to, it's a different kind of collision to actually striking the edge of the scenery, the platform, so the floor or the walls or the ceiling of a platform. It's going to be when our player actually overlaps the coin sprite. So when the sprite representing our player overlaps, so it's kind of it's not a collision in that sense. It's detecting an overlap rather than actually stopping it moving forward. So what we can say, if we use our global class here, and there's an overlap function on there, and we can say that we want to set an overlap style collision between items and the player, and we get the option now to actually push through a callback. So there's a number of ways we could do the callback. We could use a lambda function, but we're gonna keep it quite simple. So we're just going to define a callback. So we're going to call it collect items, collide items. That's our callback function, and we're going to define callback function down here. So function collide items, and we're going to come back and tidy this up at some point. But in there we'll have our coin, which is a type coin, and we're going to have our player. Which is of type player, and this is going to be, this expression is going to be return. This is where fuel stable goes through the roof here. It's going to be void, but in functional speak it's going to be unit, so no value in that sense. Beachcast, welcome to the stream. Good to see you. Nice to have you join. Have I don't know, what will we have? Let's have some Electric Alpha again. Yeah, the music's Relax Daily, one of my favourites to code to. So in here we're going to do the collect function, which will increase our score and kill the coin off. So interestingly enough, it's still complaining about that. So let's just build again. It's gone now, you see. not found coin, so we just need to bring in coin. So control dot on coin. He doesn't want to bring coin in. Okay, well that's an object. Objects coin. And now that should build nicely. It's still saying it's got a problem. Type not found coin. Build and see what happens. Oh, it still says it doesn't know what coin is. Oh no, it's built this time. Am I just suffering from weirdness due to Visual Studio Code or what? I think it's fine. Yeah, it's fine. Yeah, just weirdness due to Visual Studio Code. Pure Snable doesn't understand how void works in a world with only expressions like Haxe claims to be, but it could be void as I think void is the same as unit, and I don't know if it's. You see, Haxe seems to have its roots in ActionScript, and I don't know anything about ActionScript, so whether they used that terminology as void for meaning unit in ActionScript, I'm not sure. But it is confusing how you've educated me very well, Pure Snable, to understanding the difference between void in the C# world and unit in the F# world. But I think that's how it's supposed to work. I think it's just unit. Okay. Right. So let's go and put some coins in, shall we? So let's go and look at our editor. So here's our level. As you can see, it's just a short little level, so it's just a kind of for playing around with. And we've got some platforms, and we can put some coins around here, can't we? So let's create a new object layer. We'll call this coins. And on this object layer, we're going to put some coins. So we've got the insert tile tool selected, and we've selected the coin here as our object. So this is going to just indicate where we're going to put coins. Okay, so what we could do, we could have a couple of coins there, can't we? Maybe a couple of coins here. We'll have an easy coin to pick up straight away. I don't know where to put coins. Maybe a whole bunch of coins up there. We want snap to grid on here. I don't feel that those coins are particularly in the right place. Oops. Oh dear, dear, dear. How do we remove them? Delete. That's what we do. Delete that one. Some of these look a bit wonky. So there should be I thought there should be a snap to grid somewhere. What have we got here? Commands. We don't have any commands. Layer, group, duplicate, merge. Layer properties. Lot opacity, color. Don't seem to have a. We don't seem to have a snap to grid. Let's just try to place a whole bunch of coins here. Okay, that'll be enough. That'll just prove it. We know that we can generate these coins and collect them. Okay. Right, so we've got a coin layer, and we've locked that away now. So now we need to drag in the coin layer into with our level loader. Okay, so let's go and look at that. Our level loader. So we're going to have something very similar here. Let's load the. Now remember, the order that we load things is important here. So we're loading the background, then the map, and then the player. So we want to load the coins in between the map and the player. So let's do it there. So very similar piece of code here. So if tiled map dot get objects, get layer, sorry. Coins is not null. Then we know we've got that. So in this case, we don't need to have the necessarily have the trace, because it's quite possible that there aren't any coins on a player, on a level. But it's unlikely, but we can say that. So once again, var coins layer, as a tiled object layer, and we're going to get that by casting it from tiled map get layer coins. So if there is a coins layer present, we're going to grab it, and then we're going to iterate through all of the coin objects which are on that layer and place them within the game. Okay, so we're going to say for coin in coin layer objects. Okay, and then within there we're going to say on our state items, we can add these items to these coins to our items group, and dot add. And it's going to be, we're going to have a new coin, okay, and it's going to be the X and the Y coordinates from our map, from our level. Okay, and we've got to remember that we need to, as for the player, we need to do this offset because of the different origins. Let's just put that comment in here as well, so we know why we're taking 16 away from the Y value. Okay, and I don't think we need to have anything if there isn't a coins. If there isn't a coins layer, then we're fine. We just don't place any coins. This is coins layer. And that should be coin. And we're going to bring in the reference, the import reference to the coins, the coin class. And we don't need that macro thing there. Okay. So, what have we done so far? We've marked out in tiles where our coins are going to appear. Okay, and we've loaded that layer with the objects on it and placed the coins within our game. The coins have a collect kind of method on them, and over in play state we've said that when our player overlaps with a coin or anything within the items group, then we're going to this collide items will take a coin at the coin and the player, and we're just going to call collect on that coin object. Let's see what happens when we run this. Okay. The first thing I see that I don't see any coins. There are no coins appearing, so let's figure out why that is. Right, so in play state, yeah, Copybeard is here, the pudding, yes, he's been with us for a little while. How's the fruit and veg going and the flowers, Copybeardy? I noticed that you said that you plant some turnips. Okay, let's have a look. So we're adding, I think we need to add items. We need to add them after the player. We'll try that. And I think we need to call level loader after we've created the items, and I think actually we should add items. Oops. I think we probably should add the items here. Let's see if that sorts it out. So run the build task. Still no coins. Okay. Didn't name it. No, I don't think that's actually going to do with. That's the object, isn't it? That's the object. So that's not connected. It's just that object is cool. Okay. Let's check our code again. So we've created our items and our player. We've loaded our level. Level loader. Called coins. Coins layer, tiled object layer. Coining coins layer to objects. Is reasonable. At the state, add to the items a new coin. coin X and coin Y minus 16. Let's put an else in there. We can take it out afterwards. So did we get any messages? Nothing there. I think it was F2. To why we've not got anything. We haven't got anything at all, have we? Okay. Once again, we've got something weird going on. So these are all the coin objects. Right, okay. Yes. Okay. Let's have a quick look somewhere else. Where's the best place to look? I'm not quite sure what. It's something to do with the order that we're loading these in, I think. It's something to do with the order. What could it be? Make sure we're adding the coins, the item group, to the state after we've called a load level. So there's load level. We're adding items. Maybe we should try adding my original idea, which was this, but I'm not convinced. Let's give it a go though. Let's eliminate any problems due to that. No coins. Pretty sure we should see some coins. definitely aren't any coins there. Okay. Let's look at our load level again. Okay, well, let's try another approach to this, shall we? I'm just thinking that this code here is very similar to this code here. Maybe we should try and refactor it. Okay, let's give that a go. Okay. So okay, let's create another function. So let's create a function. Static function. What should we call it? Get level objects. What we're going to pass in there, we're going to pass a map, which is a tiled map. And we want to pass in a layer, which is a string. And we want to receive back an array of tiled objects. Okay. So if map is not null, map dot get layer not equal to null. Then what do we want to do then? Then we want to extract the map, the layer of our object layer, which is going to be a tiled object layer. That's going to be equal to a cast of basically this. And this is going to be a variable layer. and then we want to return all the objects. Okay, so instead of doing this here, what we can say is for coin in get level objects, and the map is going to be the tiled map. The layer is going to be coins. What else to be passing? So that should bring back an array of coin layer objects. Then we're simply going to say that state.items.add new coin. I wonder why it does that. New coin, coin.x, coin.y minus 16. And then we can do exactly the same for the player. But we don't need a for loop because there's only one player. So we can say, get rid of that. Oops. Get rid of this. And here we can say that the player position is going to be get level objects, tiled map player, and the 0th item from that, and then simply at the position of the player, and that should replace that code. Okay. What's it complaining about? Oh, we need an else. So we can put a message out which says something like object layer it's not found. And then simply return an empty array. Okay. This map. Okay, let's see what that does. My fear is it doesn't make any difference. It doesn't. The player appears okay, so we know the code is good from that sense. Okay. This is one of those problems again, isn't it, where it's not exactly obvious what's going on here. So, play state. Load the level. Can we put a breakpoint in here? See what happens if we run this. I'm not quite sure how to run it in debug. Let's try build again. It's not stopping at the debug, is it? So let's see if we can figure out how to run debug. So Haxe Flixel run debug. So it comes with a debugging overlay. We've seen that. Press F2. So we've removed the no debug. The log window is used to display traces. Flixel.log.redirect traces is true. Let's try that. It says we can put breakpoints, but it's not exactly telling us how to set a breakpoint, is it? Let's try running it and see if we can see something in the log window. So let's in the level loader. Let's add that. Object layer coins was not found, so that's our problem. Object layer coins was not found. Okay, well, at least we know what the problem is. I kind of suspected it, but at least we've proven it. So it's not finding our coins layer. Here's our coins layer. Have we saved? Oh, I bet we haven't saved. Okay, well, let's try this again now then. If it was just not saving, it's going to be a bit of a pain, but at least we've managed to do a nice refactoring to get this get level objects thing. There we are. There's our coins. Thanks for that. Okay, so now we should be able to run forward and grab the coin, and it disappears. And then we should be able to jump. There we go. Oops. There we go, so that's working. So we can collect coins. Okay, well that's good. Okay, and we learned a little bit about debugger, which is good. I wonder if we can set. I wonder if this could be set globally. I think what we'll do is we'll remove this from here, and I'm wondering if we should go to our main class and just set that there. So all our traces get redirected towards our debug log, which will be good for the future. And then level loader, we can lose those imports. Keep our imports tidy. In fact, tiled layer currently we're not using, so we get rid of that as well. Okay, that's good. Okay, so we know now that we're actually getting these. We're collecting coins, so our points should be going up. Is that level editor part of the main game? The level editor is a separate program. This is called Tiled, which is a fairly well-known open source 2D kind of tile map editor. So that's what that is. So what we're doing, we're kind of interacting with it. The Haxe Flixel library has add-ons which will interact with the tiled editor. So these are all objects defined for the tiled editor. All we're doing is basically we're saving our TMX file, our level data, into our data directory here. So level TMX, okay, and basically what that's doing is that means that this file makes these objects and these layers available to us within our program. Yeah, it is pretty cool. The integration is really good. That means here you see we just pass in our map as a tile layer and just add it in, and it just paints it in the background. All the graphics that we need are in the images. So here's our items sprite sheet and our kind of world sprites, and then the player is our sprite sheet for our player with the animations in it. So it all just brings it all in. Back in the day we had our own custom made level editor which exported XML and JSON. Well, in fact, if you look, basically if we open up data, I open up the TMX file, it's an XML file. Okay, it's got the graphics are all this base 64 encoded string here, but here's the objects we've placed. Here's the player, and that's where the player is, you see, and that's where all our coins are. Okay. You can export it in lots of different versions. You can do JSON and other kind of formats as well, but TMX is a default. It's just it's an XML file basically. Yeah, I think it's pretty cool. It enables you to use kind of best of breed level editor really. Okay, so let's display some information about how we're getting on in the game, how many lives we've got, how many points we've got, and things like that. So I think we need to add a few more things to this. We'll put an indicator what level we're on. Public static file level int and I'm just wondering where to have a time. We'll have time as well. I don't know if we'll use this straight away. We'll set that to at 5 minutes, 300 seconds. Let's see if we actually use it. Okay, so that's our rig. So let's create a display. So in our states we'll create display. Display.hx. Okay. So class display, and this is going to be so rather than being one sprite, we're going to want some text sprites, aren't we, to show the level we're on, what the score is, how many lives we've got. So we could make this a sprite group. So we can extend the Flix sprite group. class. I don't think we want types. Okay. Okay. So, first we're going to call the super constructor, super class constructor. Okay, so what do you want this to do? We want to display the score, don't we? Okay, so let's say we want a text object. We don't want to do super there. That's going to be in the new. So let's start that off. So public function new. That's where we want to call our base class constructor. Okay, so we'll do some other things in there. So we want to have some text. So let's do private var text score. Okay, and that's going to be a text sprite, which is of type Flux text. We're going to need to. Oh, interesting. Well, I thought we need to bring that in. Okay, we'll see. Okay, so let's now display some text. Okay, so we're going to say text score is going to be a new Flux text object. Okay, it's going to, what position it's going to be in. So let's say it's going to be in position 4, so it's going to be, you know, near the top corner. And then how wide should it be? Well, if we put 0 in there, that means it's going to be auto size, as you can see. So field width, which is the next thing we need to put in there, is going to be 0, so it will auto size itself. So we'll make sure it auto sizes. Okay, and then we're going to add text score to our state, to our group. Okay, now we need an update function. So we're going to override the public function, and this is going to be update. Okay, and that's going to take elapsed, which is a float. This is the elapsed time. Remember, this update function will be called 60 times a second. Okay, so then we're going to say that text score, and that's going to the text on that is going to be equal to the word score. Oops. Let's return, and then we're going to add reg.score to it. Okay, and then we're going to do super.update. Okay. So all we're doing currently is simply displaying the score. Right. now we need to kind of add this display to our play state. So here's our play state. So let's add something up here. So we're going to hit private. Display. So type display. In our create, we want to basically say that display is a new display. Make sure it knows about that. Private var. Okay, so we've created a new display. We load our level, add our player, add our items. Now we just want to add our display. So let's see if that will build. What did it say? Characters in reg. Capital I for int. Okay, I can't see score there, but it so I reckon, I think maybe it's off the top of the screen. So are we just not seeing it? That's our level editors look like. Yeah, so it's up here somewhere, so we're just not seeing it, are we? Why aren't we seeing it? Looks like our window's not quite big enough. So our map. "15 tiles high." Let's go and have a look at our. That's not what I want. That's me, bot. Okay, main here. So here's the window is 320. Make it a bit taller. There we go, there's our score at the top there. Okay, so I'm just going to get I'll be back in just 1 second, I'm just going to get a drink. That's better. Okay, so we got our score there. So if we run ahead, score is now 20. So we get some scoring going. Jump up here. So interestingly, unfortunately, what's happening, of course, is our score is not moving with us. The score's gone. We want that score to scroll along with us. So how are we going to do that? So we need to scroll. We need to make able to scroll. So let's go look at our display. So here we've set the text score there. We've got a scroll factor here. So this scroll factor is a flux point. So controls how the object is affected by camera scrolling. 0 is no movement, e.g. a background layer. 1 is the same movement as the foreground. Default is 1, 1. So let's try setting that. That was a flux point. Let's try setting that to 0, 0, which means it shouldn't move with the camera. The camera moved us off, so it should kind of sit there floating now. Let's see if that works. We need to bring the flux point in, which is in the maths library. Let's build. Do I need a new flux point? Is there a method off here? Oh, there's a get and a set. There's a get. Surely this should be a set. How do we set a flex point then? Okay, well let's see if we can find an example of that on the internet. So Haxe Pixel scroll factor. Scroll factor dot set. No, it doesn't like that. Text. Is it going to give me examples? Scroll text must be inherited. Scroll factor rather. Cheat sheet. Scroll factor dot set. Weird. There we go, it's working now. Yeah, the score is staying stuck in that top corner. Yep, okay, that seems to be working, which is good. Okay, so there we are. Prevent sprite from scrolling with the camera. That's what we wanted. It's still got that weird thing there. It's still complaining, isn't it? There's a problem in this file. What's it complaining about? Class Flixel cannot be called. I don't believe I'm calling the Flixel point. Oh, weird. No, it's gone down there. Once again, am I at the mercy of Visual Studio? Looks like it's gone there. Okay. No, it's happy now. Okay. So what we need some extra counters, don't we? One thing we could do is to add some leading zeros to that text. Rather than just have that, let's have So there's something called string tools, and then we can have left pad. That string, and we can left pad it with zeros to a maximum of length of 5. Okay, that sounds like a good plan. That's what the tutorial is suggesting to me. So we can use LPAD to left pad ourselves with zeros. Okay, let's try that. Should be lowercase s. Yep, so we got all the zeros there. Now we got 20. Yeah, that looks cool. Okay. I think we'll just ignore that. It doesn't seem to be causing an actual issue. Let's try building once again. It's gone. I think it's a Visual Studio Code feature. It's not keeping a kind of syntax error, kind of highlighting is not quite keeping up. Whether it's to do with the extension, I'm not sure. Okay, let's have some more counters then, shall we? The cat's just coming. Cat's called Dusty. He's just sitting there never a wash. So we had text time, which we weren't really sure about using. Lives, coins, and level. Okay. Okay. So I'm just going to follow the tutorial at this point. We've kind of deviated a little bit, but let's follow the tutorial exactly as it's saying here, because okay. So in here we're going to put all the other values. So text coin is going to be a new flux text. Okay. So we're going to put this. Where are we going to put it? So we can look at the width of the screen. So let's fluxg.width. So a third of the way across the screen approximately. And it's suggesting that it's going to be like 14 down, and it's going to be as wide as it needs to be. That's going to be coins. So let's just do the coins part first, shall we? We're going to add the text coins. Okay. And then what's it suggesting that we do? We need to bring globals in, so we'll do that. Okay, so let's just follow what it's saying here. Let's try just adding coins, shall we? So, we can't get more. As soon as we get more than 99, they're gonna go to 0 anyway. So we can just do two places. Let's see what that looks like. We've added the coins. Okay, so let's. I could just kind of copy what's in the tutorial, but I'm trying to learn this myself. So we've got coins, and that's overwrit the. Let's see if that just works. It does work. Okay. So we don't want to write it there though. It's overwrit the. Actually, just one thing I want to check: does it make sure it's actually the scroll factor's working? And it is good. Looking on the whole of the display object, which is good. Okay. So what's it suggesting here? So it's saying that it wants looks width times 0.33. It's a third of the way across. 14 down. So it should be below there, shouldn't it? It should be 14 down rather than 4 down. But why is it overridden it? Let's have a look at that again. So why is coins there when it should be below? Okay, let's. Oh, didn't want to do that really, but never mind. I'll just kill me bot. Come on, bot, start up again. Okay, well, let's try again. Coins. Let's move it right the way down. 34 then. I wonder if that's. Okay. Move it well down. Let's see what that does. Coins is still there. Okay. What's that all about? That's why. It's got to be coins. Okay. Okay, so we can now bring it back up again. It's too far down now. Right. And that should be 14. Was that right? okay, okay, I think I see what's going on. Let's run it again. Okay, so it's on the same level as that. So what we're going to do, I think, is not have the word coins. We're going to actually have a coin graphic sitting next to it. So let's do that. Okay, so tell you what we'll do. We'll make that 4, and we'll go with it like that. Okay, so that should now appear on the same level as the previous as the text score. Yeah, I'm happy with that. And we got lives next, haven't we? So let's do lives. Let's put that 2/3 of the way across. Lives, and we'll just have the simple text that goes lives, and that's simply going to be lives. Like that. So we seem to have overwritten the position there. So what have we done wrong? Lives. That's right, because that needs to be lives. Same problem again. Fuel Snable. Super SMB Brothers, yeah. Well, I've got some ideas to kind of smarten this up. Obviously, it's a bit kind of plain at the moment. So we need some enemies to actually fight, I think. But we'll probably do that next time. The one thing I want to do, do a hex-based kind of adventure game. This is what it's kind of building up to. I'll learn how to do this kind of thing, which is, you know, quite simple really. £100. Okay. And I've exited the level, as you see, so we need to have kind of a way of going to the next level by exiting off this edge. But we'll come to that. Okay, so that's we've still got level and timer to go, haven't we? I think we'll leave that bit there. Should we do an enemy and then call it a night? Let's do an enemy, shall we? Okay, let's do an enemy. So let's get rid of our display. We'll come back to look at the display and tartan that up a bit in a little while. Let's create an enemy. Enemy.x. Okay, so this is going to be a class. enemy, and that's going to extend the FLX sprite again, as most of the things we're working with will tend to. In fact, what we want to do is a similar thing to our coins, don't we really? We want to actually extend we want to kind of have this idea of the groups of enemies, don't we? So if we pop something in here, something like that. And we need to bring that object in. This is going to be, we don't need that, we don't need shaders yet. Objects.enemy. Don't like all these red lines that appear for no apparent reason when it actually works. Okay. Right, so back to our enemy class. Okay, so what do we need in here? So our player had a bunch of constants here. So let's pinch all of those constants and move them across to our enemy, and then just pick what we need. Let's just paste them into here. So we don't need we need gravity. We need gravity. We need a walking speed. We don't need an acceleration. It's going to kind of walk around. We need a falling speed, and we need a score amount. How much are they worth when you kill them? Okay, so gravity was set to a different gravity to the player, so 420 in the Y direction. Walking speed, well, we're going to set that to be 40, so they're going to be slower than we are when we walk. Each one is going to be worth 100 points, and the falling speed is going to be 200. So they're going to fall, once again, they're going to fall slower than we do as players. Okay. Right. Okay. We also had some other useful information here. We had a direction indicator. We'll pinch that as a variable we can change. I mean, these are constants, these inline finals. And we're going to have so make this private, and we'll have a private far appeared, and that'll be a bool. So is the creature actually visible? False. Okay. So the appeared has the monster appeared on the screen? Because it could be off the screen. It could be, we haven't got as far as seeing the creature yet, so it's not on the screen at the moment. Okay, so let's have a constructor. So public function new, and this once again we're going to have an x and y coordinates where it's going to be positioned. Okay, that's where it's going to live, and we're going to need a load of graphics. Let's go and find a graphic for our enemies. So in our assets over here, in our images, we've got enemy A, so that can be our enemy, can't it? Enemy A. So this red one-eyed creature. Let's grab that and pop it into our project. So that's platformer, assets, images. Just drop it into there. Okay, and what we can do then, we can simply do a build, and then that build macro will include that in our asset paths. So just do a build. So we need to, it's complaining we haven't called the super there. Okay. So all we did, reason we did that is so that we get our asset path set up. So now we want to do a load graphic. The load graphic, and it's going to be asset paths dot, and here we should see our monster. Can't see it. Enemy A it was called, wasn't it? What was it called again? Enemy A. I think it's definitely animated. And it's a 16 by 16 pixel tile. Right. Public function. Yeah, not the experience with Visual Studio Code can be a bit no field enemy a.png. Okay. I want to get a bit frustrating that it's underlining things in red, and they don't seem to be a problem. So that's in the images. So asset path dot. It doesn't want to find it now. Why doesn't it want to find it? Kev Griff, thank you very much for the raid. Hello there, welcome to the stream. So I don't know if people are still watching adverts or not, but here's a bit of a shade of fun for you. Yeah, it's a raid. Thank you so much for the raid, very kind of you. Inline and constants, I see you comment there on from Fuelstone, but inline and constants, yes. So yes, it's all in line. So basically the constants, the variable name just gets wiped out, and it's just a direct replacement of the constant value. So it's quite good from that point of view. Thank you for the raid, Kev. That's very good to see you. Okay, so we're working on Haxe. We got a bit of a weird one going on here in that it doesn't seem to want to find my. I'm a bit. Here's the file. We just dropped this file in here. It's a PNG file in our images directory, and it's supposed to find them. It thinks there's an error in here. I think that's the problem. Unexpected comma. Where have I put a comma? Line 19, unexpected comma. I don't see it. So that seems to be functioning okay. It still thinks there's a unexpected comma at that point. Unexpected comma. Characters 26 to 27 on line 19. Well, I don't believe there are any characters at that point. What's it talking about? Anyone spot anything in chat? Because I can't see anything wrong. I know it's gone. Let's see if now we can do a load graphic. Asset paths. Enemy's not there. It's got level, images, items, player. Let's have a look. Enemy A.png. we build, it should build the asset path, just like it's done for every other thing we dropped in there. But it doesn't want to see them. No, it doesn't believe they're there. Class asset paths has no field enemy __ PNG. Well, there it is. Yeah. How interesting. That's like a glug of wine on that one, I think. I do come across most interesting issues with... See what I'm going to do? I'm going to close that. I'm going to start it up again. Was that a when in doubt restart Visual Studio Code issue? I think it probably was, wasn't it? So it's quite happy now. It's found it, auto-generated the path to asset images enemy A PNG. So that's what asset path is supposed to do. It's a build macro which is automatically going through and building strongly typed references to all my files that I put in here. But that was very interesting. So let's remember that. Close Visual Studio. So now we wanted to set some animations up. So there's going to be walking along animation, pardon me, and being dead or squashed animation. If we look at the actual graphics, you can see this is walking along 0, 1, and 2, and the squashed one is dead. So you can kind of make it bigger. You can see there. This is strolling along on its patrol, and then there's the dead version, which is squashed. So that's what we want to animate. So set animation up. Animation.add. This is going to be we're going to call this walk, and this is going to be an array of frame 0, frame 1, frame 2, and we're going to have 12 frames of animation. Animation to add, and this is going to be dead, and this is going to be frame number 3, 12 frames animation on that, and then we want to animation dot play. And so when we first come across him, it's going to be just strolling along, doing his guard duty. Fjord's neighbour was planning to take it a bit easier today, as I had work vacation during Easter, but he got an incident instead. What I did, Fjord's neighbour, today is I took the afternoon off, having worked late Friday and Saturday morning. So I took the day. So I had an evening. What was your incident that you got, Fjord's neighbour? Was it a doozy, as they say? So we want to set the size of our graphic. So the graphic that we're using, the tile is 16 by 16, but as you can see, the actual enemy is considerably shorter than that. So we're going to set it to be 12 by 12, and we're going to move this is the origin here. We're going to move the origin down 4, so it's going to be this kind of area here. It's going to be the kind of collision. So you can fly through the top here. The collision box is going to be around this kind of lower half of the graphic. So let's have a look at doing that. So so we're going to set it to the size of 12 by 12 pixels, and then we're going to set an offset. And we're going to go down, we're going to go across 2 and down 4. Okay, so that's kind of squashed the collision box to be a bit smaller than we want. Set its acceleration in the Y direction to be gravity. And the falling speed, acceleration in the max velocity rather, when we're falling, is going to be and it's in the Y direction, is going to be its falling speed. Okay. Oops. Okay. Offset.set, I think it is. Yeah. Okay. So now we've got a constructor for our enemy. Now we need to create an update function. Once again, remember the update function will be called once every frame, so 60 times a second. So all of our sprites, flexible sprites, have got an update. So we're going to call this. We're going to override the public function. It's called update, and once again this takes an elapsed time, which is a float, and we do want to call super.update, passing the elapsed time into it. That's the last thing we'll do. So up here, what do we want to do next? Okay, so we're going to want to make it walk along, but it's got to stay inside the bounds of the world. So if it falls outside of the bounds of the world, so if it's not world bounds, if not in world bounds, then what we want to do is to say that it exists, which is a property of all sprites. It's going to be false. So if we kind of fall outside the bounds of the world, which is our kind of view onto the world, then we're going to cease to exist. So bye bye. Let's have some more. So if then we say is on screen. If it's on screen, then appeared going to be true. So we're just setting some state on the enemy, depending whether it's fallen outside the bounds of the world or if it's on screen. If it's not on screen, it's not appeared, so we don't need to do an awful lot with it. Then we're going to say if appeared and it's alive. Once again, alive is a property of sprites, so if it's alive, then we want to move. We haven't defined the move function yet, but we're going to submit. Then we have, and then we're going to say if just touched. So if we've just been touched by a wall, then we're going to flip. So if we're going to patrol between two walls, and then we're basically going to flip our flip our direction. So flux object, we hit a wall, and I think we're going to have to bring that as an import. So let's just save that. Oops. And whoops, what have I done wrong here? Not spelled update right. So we just need to bring that in. Now we need to create a move directory, a move function as well. Do it down here. And we can import object. So if we've just touched a wall, then we want to flip direction. That is flip direction. Which is something we need to write ourselves. We'll create a flip direction as well. Okay. Okay, so what's move going to be? Well, velocity in the x direction is going to be our direction times our walk speed. And then flip direction, we're simply going to change. So we're going to say flip x is equal to not flip x. And then we're going to change our direction. Okay. Right. Okay, so that's our enemy. We don't need that. We need to do something in terms of our player now. Should we? So this basically means our enemy is going to patrol between 2 points. It's going to go backwards and forwards. So Fjord Snapper says there was some deactivated service accounts which caused one of our services to fail. But thanks to micro-configured alarms and misleading metrics, we missed it for a while. It's non-critical, so nobody saw it for a week. So now they've got a week of backlog. It's probably okay by now. Well, I sympathise. I'm not responsible for setting up alarms or responding to alarms. ZPRDZ, thank you so much for the follow. Have some electric elf hypes. Thank you so much. So that's at 390. So we're motoring now. Thank you very much for that follow. It's very much appreciated. Yes, as I say, I'm not responsible for setting up or responding to alarms, but the number of alarms we haven't got set are quite alarming. So things like running out of disk space. So I regularly just log on to various servers which are quite important to me, and and make sure we've got enough space. Electric Codebase Alpha, yes, we'll share this. Electric Codebase Alpha. That's yeah, very cool. There it goes. So these are shaders. These aren't videos. These are actually being computed in real time on the GPU. So they're pixel shaders, vertex shaders that Fuel Snable and I, mainly Fuel Snable, develop live on stream. So if you're interested in how these kind of things are produced, here's another one. Here's Hype, hyperspatial Hype, with our alien friend Alf. Then just check out some of my videos on YouTube. You'll find it all there. Okay, so I do want to try and get into shaders with this with Haxe. But that's going to be a little while down the road, I think, because it's a whole new thing for me to learn. Okay, so what do we want to do? We want to interact with the player with this monster, don't we? So let's go and look at the player. The player's got what's the player got? So the player's got a move, and inside move, then he's got this jump force. So if you press the C and they're touching the floor, they're going to jump. So I think we probably need to do something about kind of pulling that functionality out. So let's start off with that then. So let's create a jump function, shall we? Let's do it here. So private, make it a public function. Jump, and in jump is what we do in jump is to set that. And then all we can simply do is say that here we want to just jump. Okay. So that's encapsulated our jumping. So when we jump, we're going to be able to do other things, though. Okay. Right. Let's go back to our enemy. So this has got to be able to interact with the player in some fashion. So when the player jumps on top of the creature, the enemy, then the enemy will be destroyed. But if we touch the enemy from the left or the right, we're going to be killed. So let's go here. Let's create a public function. Call it interact. And we're going to interact with an interaction between a player. And the player is of type player. So we're going to have to bring player into our imports. Okay. So what's the interaction actually involve? Well, if our monster's dead, then the player's safe to walk around it, bump over it, whatever. So we can say if not alive, we're simply going to return. There's nothing to happen. So that's our kind of get out of a guard clause. Only when the monster is alive is it going to interact with the player. So then we want to say okay, so flux object. Okay. Right. So we need to know what direction the player is coming from to touch the enemy. If it's coming down from above, then what's going to happen is the monster's going to die, and then the player's going to be propelled upwards in another jump. It's going to bounce on top of the object, on top of the monster. So if we say if player velocity y is greater than 0, i.e. it's moving down. Remember, if it's got a velocity of negative y, it's moving up, and positive y, it's moving down. So if you think of it in terms of the origin being the top left hand corner, the positive y direction is down. And is touching. Is it touching from above? So if you think of the collision box around the enemy, the top up is the top level, the top layer of the that collision box. Then the player is obviously touching on the up. Then we're going to kill. We're going to die. So we're going to say kill, and then the player is going to bounce. So player dot jump, which is why we extracted that jump function as a public method, public function. Okay, it's on the player. So now we can call this from our enemy and make the player bounce on top of the monster. If that's not the case, then we're going to kill the player. Okay. So we've kind of got the basics of our monster interactions. The monster is going to just, when we create it, when it's visible on the screen, it's going to move, and it's going to move in its walk speed. And if it hits a wall, it's going to flip its direction and walk back. Otherwise, it's going to interact with the player if we jump on top of it. Okay, so in terms of calling interact is where we don't do it at the moment. We don't call the interact, so we need to remember to do that. Let's create an enemy layer, shall we? Enemies. We'll just have the one enemy for now. And we'll have an enemy that's going to patrol in this area here. So let's grab the enemy, and we're going to just place it there. In fact, we're not going to place it there because that is whoops. Delete it. Let's place it there. Okay, so we got one enemy. That's enough to be getting on with. And we've got to remember this time we'll lock that layer off and we'll save. That's what we forgot last time. It's just what I forgot to save it. Okay, so we've got an enemy. Okay. So that's enemy place. Let's go to our level loader. And we should be able to load our enemies exactly the same way as we've done with coins. So let's do that. Okay. enemy in enemies layer. Enemies dot add new enemy. Should be okay. The enemy, so we need to bring that in. Import objects to enemy. Okay. Okay, so let's see what happens. Let's run that now. Interesting. Enemies. Yeah, I think it could be quite interesting playing with some of the libraries that come with Haxe or are available for Haxe. So it's getting stuck, isn't it? There, Haxe selects all 62%. Why has it got stuck there? Let's just comment this out for a second. Oops. Got used to using Code Rush and having that ability. Okay. I just killed me bot again. Okay, right. Let's have a look. So this was causing it to crash. Add new enemy. So let's just uncomment these bits. Sure that works. Yep, okay. So it's obviously creating our enemy, it's the problem. So where's our enemy? Okay, speed 40, score 100, blah blah blah. Prepared and alive. Move. Okay. So we're getting stuck, aren't we? Dark Knight, thank you for the follow. Excellent stuff. Thank you. Have some shader fun with Electric Elf. Okay, so we're getting stuck creating our enemy, aren't we? So let's go and have a look in here again. Okay. So we call the super constructor, load our graphic, add our animations, play the walking animation, set the size of our collision box at the offset so it's smaller, set the acceleration and the max velocity, and then we're not in the world bounds and exist is false. If we have appeared in the screen and we are alive, then core move. If we just touched a wall, then flip direction. Call the super function update. Move simply means we walk in the direction of our walking speed, either to the left or to the right. Flip direction simply flips our graphic. This flips the sprite about the X direction and then changes the direction. Interact, if we're not alive, let's comment out. Interact should be okay, we're not calling interact at all. Check this. There's our monster. Oops. Select object, that one. Just move him a bit closer because we might be able to see him. Save that. Enemies. Level loader. Oh, I've not added them. Oh no, I had added enemies there. So where's my play state? Enemies. I think we need to set enemies up here, don't we? So enemies is going to be a new typed flicks group of enemy. So we can't add to it because of that. That's the problem, I think. Let's try that. There we are. So we got our enemy should be down here. He's not appeared. Bit of a pain. Let's go. He's not there. Should be in that part, shouldn't they? So there's something slightly wrong with that. Level loader for enemy. Get enemies. State enemies. Add. And then I think the problem is going to be in the play state. We're not adding enemies. So we need to do add enemies. Okay, that makes a lot of sense. Let's start it up again. There we go. So what happened is our enemy was there, but he fell through the floor. So we haven't set up collisions for the enemy. Stop it, make him collide with the map. So that is here. So what we want to say is what do we want to say? So it's going to be another overlap, isn't it? So let's pinch this bit of code. So this is going to be enemies. Enemies is a group, remember. It's not particularly one sprite, so this is going to affect a load of sprites. We'll have a collide enemies function, and that's going to be what we're going to call the interact. Collide enemies. That's going to be enemy. And that's going to be of type enemy. And then our enemy is going to interact with our player. Okay. And we also want enemies to collide with themselves. We'll say fluxg dot collide enemies. So if we have two enemies that walk towards each other, they'll collide and bounce off. Okay. Okay. Let's try that then. Let's see if our enemy stays in place and starts patrolling. He fell off again. Oh, we need to collide with the map as well. So we need to do the same here. So then enemies. Sorry, that's map. Enemies. Try that. I don't want to end another stream with characters falling through the floor. There we go, so now we're working. So he's not patrolling exactly, is he? He's simply just going through his walk animations. So he needs to be moving backwards and forwards, really. Let's see why he's not moving backwards and forwards. So, enemy. If appeared and alive, if it is on screen, then appeared is true. Because I think we think appeared is false by default. Yes, we did. Let's try that. Yeah, there he goes, walking off, and he disappears off the screen. Does he come back? He does. There's a patrolling enemy. So now, if we are foolish enough to jump up here and to walk along here, we got killed. Okay, so we need to decrease our lives, etc. But let's give that another go. I'll see if I can. This is where my the fact I can't play video games is going to hurt me. We'll see if we can land on top of him. No. Got we need to respawn, but we'll have one more go, and then I think I'm going to call it an evening, because we got in a decent position. We've got an enemy that's patrolling along. If we hit it, we die. We need to kill it, really. I think the problem is we might. Yeah, we got it. There we go, and we bounced up. So that means that's working. So we need to put a death animation in, so that we have a squashed enemy rather than just disappearing straight away. And we need to get some points for that, and we need to look at lives. I think that's a decent position to be finishing off in. Gnome Jodas, is this a personal project or a commission? No, this is actually just a tutorial. Good evening to you. It's good to see you. Have a salute from Alf. Welcome to the stream. What we're doing is we're working through a lengthy tutorial so that I can learn how to program in Haxe, and we're using this this platform game as a way of doing that. So it's a very simple single level at the moment. This is the level. It's not particularly imaginative, but it does have some obstacles, and it has some platforms, some coins, and it's got a single enemy so far. We're going to have different types of enemies. We're going to have power-ups. We're going to be able to go on, leave the level and go to the next level. We're going to have all the scores and lives and all that kind of stuff. Music, sound effects, all that kind of stuff is going to be part of the work we're doing. So there'll be a series, probably another 2 streams, perhaps, maybe 2 or 3 streams, to get to a position where it's using this level. It's kind of it's all working, and then we'll come back and just smarten up the graphics. Have a nice background, have some trees, have a mid-ground, maybe have some parallax effects, all that kind of stuff, just to try and get it to be a reasonably polished game. Currently, we're if you look at over here, we're running in a browser. So this is HTML5 target. But with Haxe, I don't know if you know anything about Haxe, we can target lots of other different things. So we can target Adobe Air, Android, Electron, Flash, something called HashLink, which is a virtual machine, very fast virtual machine. Nico, which is a virtual machine. We can target Windows as well. So we've got lots of kind of things we can compile this to. At the moment it's JavaScript it's compiling to, of course, HTML5. But yeah, this is a framework called Haxe Flixel, which is based upon Flixel, which was a Flash development. So Flash has gone the way of the dodo now, but we're using OpenFL as the underlying platform for this. And because I mean, with Haxe, it will compile to JavaScript. We can also compile to C++. It can compile to C#. It can compile to lots of different targets. So it's very much a general purpose programming language, which was developed specific for games. But you can use it to write React code, for example. But you use the Haxe syntax, which is really nice. Very happy with the way Haxe works itself. Strongly typed, kind of functional and object-oriented. It's got features such as partial application of functions. It's got algebraic data types in the forms of enums. It's got kind of functional programming aspects to it. It's got object-oriented aspects to it, class-based and all that. So yeah, it's a pretty impressive little programming language actually. I'm quite enjoying learning it. But this is a second stream, so you know I'm not that advanced with it yet. And I've got to say I'm not a gamer, so it's quite a challenge. I like to try and challenge myself to work with technologies and things which I've no experience with. So it's a mutual learning. So I'm learning, you're learning. How it works in HTML5, I think it's a canvas. We should be able to look actually. Let's go and have a look. HTML5. Here's the open with code. So there you go. That's the index.html file. So we've got a JavaScript file which has been compiled out of the Haxe. Maybe you know more about what this is telling us than I do, to be honest with you. I think it's all appearing in this div here, and then we're using Lime as the for the kind of low-level functions. Yeah. So it's interesting. The fact it compiles to lots of different targets is pretty good. I'm using HTML5 just because that way it's very quick to compile, because it's compiling to JavaScript or transpiling to JavaScript, and it's easily visible rather than having to build any kind of native code. But you can build native code, and you can build native code for mobile applications. And this is Haxe Flixel, so this is one framework which Haxe will use. The one thing I'm hoping to move on to at some point is Heaps, and Heaps is another framework which you can target things like PlayStation 4 and Xbox One, as well as the mobile devices and Windows, Mac, Linux, etc. So yeah, it's very flexible, and in fact there's some quite well-known games been developed using Haxe, and especially Heaps. So if you come across things like Dead Cells or Northgard, those were developed in these languages. So Dead Cells was by, is it Twinmotion? And then the actual creator of Haxe, he did Northgard. Using Edge as a browser, I like Edge. It's Chromium Edge, so it's not obviously it's basically Chrome under the hood. So yeah, I've got all the same functions as Chrome. Well, I think we've got to a position which is useful. So let's close that down. I'll push all this code up to GitHub. The code will be there for you to look at if you wish. The only thing that's not been committed will be the assets, because they're under license. But there we go, push to GitHub. If you want to know where my GitHub is, you'll find it there. I have a YouTube channel as well, where all my videos are archived. There are many hours of video up there now, so do check that out. If you feel so inclined, do subscribe. It's completely free to do so. And I'm also on Twitter, so if you feel like following me on Twitter, do so. It's at Codebase Alpha. That way you get notified when I go live. At the moment, I'm not doing any pop-up streams, and I'm only streaming once a week. A couple of reasons. One, due to the current biochemical or biological situation, and also I'm pretty busy at work, so I haven't got that much kind of energy left at the end of the day to stream more than once. But I do hope to get back to streaming it twice a week, and also doing some pop-ups at some point. Next time we're going to carry on with this tutorial, but I do want to get back to the to the old school text adventure in the bot as well at some point, because we've got some interesting parts of that, especially with the wandering monsters to get sorted. I do wanted to get back to that. I just got kind of seduced a bit by learning about Haxe, and decided to take a break, even though I've only done 2 streams on the text adventure. Take a little bit of a break from that and have a look at this. One of the big things about streaming is, especially when you're streaming live coding, is trying to find projects which interest you and you think that might interest viewers. We've done lots of things on stream. We've done Alexa Skill from scratch. We've done Microsoft Bot Framework. We built a synthesizer in C# and WPF. We've built a Z80 8-bit processor emulator and then implemented it to emulate the Spectrum 48K and played some games, albeit without any sound, but it played the games okay from ROMs. We've done loads of things. A text adventure, we've written the bot. Bot's quite interesting if you want to ask questions. You can just type !ask and ask a question, it will answer them. Answer your question for you. I'm also a space nut, especially interested in SpaceX, so if you are interested in space, then there's a launches command in our bot which will tell you about upcoming rocket launches. But it should do, it's interesting. Why is that not working? There we go. Okay, so coming up next will be a Starlink launch from SpaceX. Currently testing SN4 of Starship. Hopefully tonight they'll do a static fire on Starship and it won't explode. They've had quite a lot of fireworks, and if you've not watched any of the live streams or the videos from that, lots of fire involved, but the rocket motor, the Raptor engine, hasn't actually fired yet, but hopefully it might fire tonight, you never know. And that should be followed by a 150-meter flight and probably crash, and then later in the year, hopefully sometime in the next few weeks, we might see a 20-kilometer jump by a later serial number of Starships. So I'm really excited by that. But of course the big thing that's happening this month, 27th of May, we're going to be seeing astronauts launched above on the Crew Dragon on a Falcon 9 rocket. So that'll be absolutely amazing and exciting. So really looking forward to that. Anyway, let's wrap up for now. We've been going for a fair number of hours now. Let's go and find someone to raid, shall we? So thank you everyone who's joined. I really appreciate the follows. We are trying to chasing 400 followers, and we've got to 291, so that's pretty good. I'm very pleased. So if you're not a follower and you do feel like throwing me a follow, then please do so. Very kind if you did. Let's find a raid target, shall we? So raid a channel. So who we got? We got Source Scoot. Oh, Kev is. So he raided us earlier. I don't know if he's come back on. Let's raid back to Kev Griff. So let's do that. Do stay with the. Looks like he's on a be right back at the moment. Let's see. Source Scoot's actually active. So let's go and raid Source Scoot. Do join me the same time, about 7:30 British Summer Time, 6:30 UTC next Monday, for some more platform game fun with Haxe and Haxe Flixel. Otherwise, let's raid over to Source Scoot. So thank you for joining me, and have a good night to you all. Take care everyone, and stay safe in this current environment.